In this exercise, we will practice using the null values in pandas. We're going to load the dataset gapminder with missing values. So this is the same dataset, except that I imputed some values. Now, in this dataset, I use the value -1 to indicate that the value is missing. So we have the opposite problem here, which is that there is a numerical value which has been used to indicate that the value is missing. This is often an issue when data comes from different data sources and those data sources do not have the same data representation. Many of them, for instance, it's not possible to represent a null value. There is no specific value is used for the null value. So, these data sources, such as a text file, use what we call sentinel values to indicate null values. Here, for instance, since GDP per capita, population life expectancy, and year can't be negative, I use the value -1 to indicate that it's missing. The problem here is that the value -1 is a number, meaning any operation we do, if we don't deal with this value, is going to yield incorrect result. For instance, if we calculate the average life expectancy, population, and GDP per capita, we're going to include -1 in the calculation, hence the final number will not be correct. So first, let's calculate these numbers: the average life expectancy, population, and GDP per capita. Well, first, let's get the series. And if you want to calculate the average, there are multiple ways of doing that. We can use a built-in function called mean, which will calculate the average. Or we can use Python functions. We can do sum data life expectancy divided over length data life expectancy. That will give me the same result. Now, it's not preferable to do this for reasons that we will show in a minute. And Python doesn't have a built-in mean function. This mean function is part of pandas, so we can call it using .mean. Nonetheless, let's do the same for population and GDP per capita. So I'm going to do the same for population. That's the average value of population, and that's the average value of GDP per capita. Now, in all of these numbers, the value -1 has been incorporated. Hence, I expect that this number will be slightly off than the true values because I added -1. And I don't only have one -1, there are more. So if you go through this data, you can see that many of these values have been imputed to be equal to -1. I think 10% of the values. Okay, so we need to deal with this. One way to deal with it is to make the sentinel value to be a null value. Because once we have a null values, we can use pandas operations to deal with null values and either drop them or fill them. Let's take a look. First, we need to change -1 to be a null value. So I'm going to use the function replace. I'm going to do data.replace -1 with a null value. Again, now I have two options. Either I do none or np.nan, which I prefer because it's also a numerical value. I'm going to do this. And you can see that the -1 has been populated with a null value. Now, this function doesn't change the original data frame. It basically returned a new data frame. So now I have an option, which is either to override the original data frame, saying data is equal to data.replace, or simply creating a new data frame just to keep the original one. Next, let's do the same calculations. So I'm going to calculate the average of life expectancy, which is now 52.81. Okay, so that's data. So excuse me, that's on data. That would be the same. It's now 59.39, which is a big difference. Now, the reason it's a big difference, although this value is -1, is because when I do the mean, I don't divide over the number of observations which are null values. Hence, I get 59 because I was dividing over a large number of observations. So it's not only the question of adding -1 to the value, but also dividing over the total number of non-null values. Let's do the same for population. And now you can see the value of population. The average population is 29 million, compared to 27 million. Again, that's a big bias here when I don't deal with the null values. Finally, let's do GDP per capita here, and I get 7,200 compared to 6,833. Okay. Now, I mentioned in the beginning that it's not a good idea to use the functions in Python, sum over length. The reason it's not a good idea is that these functions do not know how to deal with null values. And here I got none and none, because sum, when I'm summing life expectancy, and life expectancy contains one null value, anything added to NaN is going to be NaN, hence nothing happens here. And that could have been worse if I replaced -1 with none, because in that case Python will try to sum none with something, and you will get here, excuse me, let's do, for example, if I add 1 to np.nan, I'm going to get nan. Now this is interesting, because if you use the built-in functions in pandas, it's going by default to drop the null values. So here, if I want to use this, I need to do drop na here and drop na there, so that I get the value, right? However, if I use the built-in function in pandas, I don't need to do the drop na. By default, it's going to drop the nas. Of course, I can drop the nas if I wish. That will give me the same result, but that's not needed because it's going to drop them anyhow. Another important differentiation here is that don't drop the NA on the data frame and then do the mean, because if you drop the NA on the data frame, it's going to drop any row that contains a null value, meaning it's going to drop a row that contains a valid life expectancy, even if there is a null value in the GDP per capita. So if I do drop NA here, that's still fine. It's going only to keep rows that contain no null values. But that means that if I take the life expectancy, I have simply lost too many observations, and most likely my number will be different than this number here. Fortunately here the numbers are close enough, but you see why they may be different, because I dropped too many null values than what I needed for this operation. Alright, so let's do some more advanced practicing over the null values. Now, this question is asking us to report the rows that contain missing values, and then the columns that contain missing values. There are multiple ways to get to answer this question, and I'm going to overview a couple of them. Let's take a look at data here. Well, actually data 2, not data. One way to detect the rows and the columns that contain null values is to basically scan through the data frame, and then the moment we see a null value, we can report the row and the columns to be rows and columns that contain null values. So what we can do in this case, we can really do a manual solution just using a loop. That's not very preferable, but that's kind of one of the solutions that many people kind of default to, having learned about loops and iterations from other backgrounds. So what I'm going to do, I'm going to create two sets, rows with missing values and columns with missing values. And then this is important, not that I advise you to do it, but this is in general the structure of a loop to go over a data frame. We go over each value in the row index, and then we go over each value in the column index. And then what we do, we can extract the value in the intersection of the row and the column. So the value should be the data2 log I and C. Now, if this value is null, so I'm going to use the function is null again, p.isNull of this value, then I'm going to add this value. I'm going to add the row to the row set, the rows with missing values, and the columns with the columns with missing values. And obviously I use sets because a column may contain multiple missing values, so I don't want to repeat the column multiple times. Okay, once I'm done, I can take a look at my rows with missing values, and those are all of the rows. Those are the indices of the rows that contain missing values. Okay, so I can actually take a look at my data here, and I can use fancy indexing again to take a look at the rows here those are all of the rows that contains missing values. Well, you can see -1 here because this is data, but if we do data 2, those are the missing values here. Now, the columns that contain missing values are CM, so CM, all the 3 columns, GDP per capita, life expectancy, and population, contain missing values. So we've already answered both questions here. The second solution is to basically drop the null values and take a look at the rows and the columns after dropping them and then comparing them using to the original rows and columns indices. Okay, let's do that. So if I take my data frame day2 and drop NA, by default it's going to drop any row that contains a null value, meaning this index here, the new index, is the index without a missing value. So I can take a look at my index here, and those are the rows that do not contain missing values. Then the opposite operation is what I'm looking for. I'm looking for the rows that contain missing values, so I can simply take data2.index, and actually it's dot difference, minus is not supported, and take the difference in between these two indices. And those are basically the rows that contain missing values. Let's compare this one with RM. You can see that those are the same numbers, right? 27, 29, 32. Those are the rows that contain missing values. Now, let's do the same for the columns. I'm just going to flip here. I'm going to take the columns of the original data, then I'm going to drop NA and take the columns here. Well, the only thing in here is that I want to drop the columns that contain nulls rather than the rows that contain nulls. So I need to put my axis to be the column axis. And again, I get the same result here. Basically GDP per capita, life expectancy, in population columns contain null values. Finally, I'm just going to do a third solution. This is the most advanced one. And in this solution I'm going to use a function called any. Okay, so what I'm going to do now, I'm going to do data2.isNull here. And that basically will give me back, since this is a universal function, a Boolean data frame. Now that's interesting. You can think about this as a mask, but it's not a mask, it's a data frame rather than being a series. Okay, now before using the function any, I want to talk about the built-in functions in Python called any. Basically, this function returns true if any value in the sequence is true. So any true, false, false is going to be true, but any false, false, false is going to be false. So you can think about this as a more generalized OR operation. It's the OR of all of these values. There's also another function called all, which is the AND of all of them. If all of them are true, it's going to return true. So it's only true if all of them are true. Okay, now we want the any function because we want to report only if there is any value which is true here, we will immediately detect that this column contains null value and this row contains a null value. So what I'm going to do here, I'm going to do data2.isNull.any. And you can see here that what I've got any on each one of the columns here. So country doesn't contain any null value, any is false, continent doesn't contain, year doesn't contain. The only one that contain null values are life expectancy, population, and GDP per capita. Okay, so well, let's do it on the other axis, on the row axis. By default, this function is operating on the column axis, and that's actually the fact for any aggregation function in pandas. Meaning if you do data2.mean, it's going actually to calculate the averages over each one of the columns. That's something we'll look at when we talk about aggregation. By default, aggregations on a pandas data frame will be applied on the columns axis. If you want to apply it on the row axis, we just need to provide axis is 0. Actually, axis is 1, to apply it on the column axis, meaning going row-wise, and we will get it to be true only in these rows that contain null values. Finally, we need to filter out only those that contain true. So the last step is to basically take this, save it in a series. Now this series happens to be a mask. So if I do, well, that's the series. If I do S of S, it's going to mask itself. And then I can take the index. So those are the columns that contain null values. Similarly, here I can take this one to be a series. S on itself is going to be masking itself, and I can do index here. And again, you get the same results in here. So those operations are not very common. Often we don't care about rows and columns that contain missing values. 90% of the time we care about dropping the null values and filling them. However, those operations are useful because they're giving us more exposure to playing with the data structure, the data frame, as well as their indices. And this is something we will get back to in the future.